service neutral is commonly uninsulated due to several factors. Firstly, cost savings are a primary driver, as it is simply less expensive to manufacture an uninsulated conductor compared to an insulated one. Secondly, improved heat dissipation is another significant advantage. Uninsulated conductors excel at dissipating heat, mitigating the risk of overheating and consequently prolonging the conductor's operational lifespan. Thirdly, easier installation is also a factor. Uninsulated conductors offer greater flexibility during installation, simplifying bending and routing processes. Additionally, the service-neutral functionality extends to serving as a messenger wire, providing support to other conductors such as the service entrance conductors. While the service-neutral is grounded, its presence is not intrinsically essential for the circuit's fundamental operation. The circuit retains its functionality even without a grounded neutral. However, the absence of grounding introduces a potential safety hazard. Without a grounded neutral, the neutral conductor would exhibit a higher voltage potential, escalating the risk of electrical shock. The impedance of the ground does not dictate the circuit's operational dynamics. The current's pathway back to the secondary side of the transformer remains exclusively through the service neutral, irrespective of the ground's impedance. The primary function of the service neutral is to provide a low impedance path for the return of unbalanced current from the load back to the source, typically a transformer. This unbalanced current arises when the loads connected to different phases of a multi-wire system are not equal. The grounding of the neutral is a safety measure, ensuring that the neutral conductor is at or near ground potential. This minimizes the voltage difference between the neutral and any grounded objects or surfaces, reducing the risk of electric shock. While the circuit might technically function without a direct connection to ground, the absence of grounding would create a floating neutral, which can lead to unpredictable voltage fluctuations and increased risk of electric shock. The Earth's impedance is significantly higher than the impedance of the service neutral conductor. The service neutral is intentionally designed to have a low impedance, ensuring that the majority of the unbalanced current returns through this dedicated path rather than through the earth. The grounding electrode system connected to the neutral at the service entrance provides a supplementary path to ground for fault currents, further enhancing safety. However, it is not intended to serve as the primary return path for normal unbalanced current. The National Electrical Code, or NEC, provides specific requirements for the sizing and installation of service-neutral conductors in grounding electrode systems. These requirements are designed to ensure the safe and reliable operation of electrical systems. The size of the service neutral is determined based on the calculated unbalanced load, as per NEC Article 220. The grounding electrode system must meet the requirements of NEC Article 250, which specifies the types of grounding electrodes permitted and the methods for connecting them to the neutral conductor. The uninsulated nature of the service neutral in many installations does not compromise safety, provided that it is installed in accordance with the NEC and other applicable codes and standards. The neutral conductor is typically installed in a manner that prevents accidental contact with other conductive surfaces or objects. In some cases, the service neutral may be insulated, particularly in underground installations or in situations where there is a higher risk of corrosion or physical damage. The decision to use an insulated or uninsulated service neutral is based on a variety of factors, including the specific application, the environmental conditions, and the local electrical codes. However, regardless of whether the service neutral is insulated or uninsulated, it must be properly grounded to ensure the safety of the electrical system. The grounding connection is typically made at the service entrance, where the neutral conductor is connected to a grounding electrode, such as a ground rod, a metal water pipe, or a concrete encased electrode. This grounding connection provides a lower impedance path for fault currents to return to the source, tripping the circuit breaker or fuse and energizing the circuit. The grounding electrode system also helps to stabilize the voltage of the neutral conductor, reducing the risk of voltage fluctuations and electrical noise. The service neutral plays a critical role in the safe and reliable operation of electrical systems. Its primary function is to provide a low impedance path for the return of unbalanced current from the load back to the source. The grounding of the neutral is a safety measure, ensuring that the neutral conductor is at or near ground potential. The uninsulated nature of a service neutral in many installations does not compromise safety, provided that it is installed in accordance with the NEC and other applicable codes and standards.